Okay, so it's time for our last but not least talk with two speakers this time. So Eduard Agavriloae and Matei Josephs. So Eduard is a senior pen tester focused on cloud security and web exploitation. And Matei is a security researcher who can boast several CVEs under his name. They joined their forces to improve the security of cloud resources. This led them today to talk about the journey of searching for secrets in public AMAs. So the stage is yours.
Thank you. Thank you, and hello, NoHat. It's a pleasure to be here. You have a very cool conference, and we hope to come here again. This is an updated version of what we presented at DevCon this year. Essentially, it's a research we've done together where we search for secrets in public AMIs, and it's both technical, but we also have some cool stories with us. My name is Eduard Agavriloae. I'm a cloud security researcher. I'm working towards being a trainer. I'm a contractor for SynCubes. And while I did this research, I was a senior penetration tester at KPMG Romania. They sponsored this research, and they allowed us to do it. So I want to thank them. And to tell you more about this research, I want to tell you how we came up with this idea. I was doing an AWS cloud security configuration review for a client of SynCubes. And I got the initial access. I ran some automated scanning. And I was looking through the results. And I saw some findings for S3 bucket, CloudTrail. And when I saw the EC2 dashboard, I saw for the first time AMI is set to public, which is a critical finding. But who knows what an AMI is? Okay, that's a lot of people. And who used at least once an EC2 instance? Okay, basically the same people, but well, if you used an EC2 instance at least once, you know what an AMI is because you had to choose one, right? Every time you start an EC2 instance, you are choosing an AMI. And an AMI is like a snapshot of a virtual machine. So you have a virtual machine, you put some files there, configurations and so on, you make a snapshot, and then you reuse that image to start new instances from that baseline. So that's what an AMI is. And you have official AMIs from the AWS marketplace that are here, and you also have something called community AMIs, which are published by anyone. Cool. Now, an AMI can be both public and private. And by default, every time you create an AMI, the AMI is private. But the issue can appear when you make it public and you don't want to be public because you have all these files that you already pre-configured in the image. And if it's public, then it's accessible by anyone. And while I was doing this cloud security configuration review, I discovered that this client had 5 public AMIs, and I was very curious to see what was inside of them. And I went to the client and I was like, hey, can I take a look inside of them to better verify the risk that you were exposed all these years? And they said no, which made me regret even asking. But I got something better in return. I got this question that kept me awake at night, if there are any public AMIs with sensitive data out there. And I kind of hoped that they are, because if one company had 5 public AMIs, surely there are others with public AMIs as well. The question was, what was inside of them? Now, when we started the research, we wanted to do it so bad that we haven't checked any previous work, but when we were in the middle of it, we identified this work done by Dolev Farhi. He scanned based on keywords, AMIs, but from a single AWS region. And we wanted something more complete, like scanning from all AWS regions and not limiting ourselves only for keywords. And then we also saw some similar work done by Ben Morris. He searched he searched for secrets in public ABS snapshots, which is similar to our work. An ABS snapshot is essentially the volume from an EC2 instance, but we'll see shortly why there's very little overlap between his work and our work. Now, starting the research, we set some goals: to dig for secrets in every public AMIs across all AWS regions, have some fun, do responsible disclosure if that's the case, and one hidden goal was to get some bounties, and my colleague Matei will tell you more how that went. As a starting point, we had to collect all the AMIs, and in order to do that, we had to use the AWS CLI. The reason for that is because by default, AWS deprecates the AMIs 2 years after they were created, and you also can deprecate the AMI whenever you want, right? And we had to include this flag, include deprecated, which is not available from the web portal, and that's why we had to use the AWS CLI. And collecting all the AMIs, we gathered 3.1 million AMIs, and we shortly figured out that we can't scan this much, and we had to do some filtering. And for example, we removed AMIs from Marketplace. We consider that since the AMIs are from Marketplace and a lot of people are using them, if there are secrets, the secrets are reported, and there are less chances to have secrets in those AMIs, so no scanning of those. On the same idea, we removed AMIs owned by AWS. That left us with 1 million AMI. And we did something like a trade-off. We removed owners that had more than 50 public AMIs. And the reason for that is, if you have more than 50 public AMIs, you are either an unofficial publisher of AMIs, or security-wise, you are in a point of no return, and then there's no point in scanning and helping you, right? And that left us with 27,000 AMIs, a number a lot more manageable. And we did some fine-tuning when we removed AMIs with more than 3 volumes or volumes bigger than 200 gigabytes. We had some AMIs with 17 volumes or with volumes of 20 terabytes. And for our time and budget, we had to remove those. So we got, in the end, a number of 26,000 AMIs, a number that we felt we can work with. This is the distribution of AMIs after we did the filtering. We have the US East 1 region with the most public AMIs, and the region with the smallest number of AMIs was Israel Central 1 with only 30. And at the time we did this research, there were only 27 regions in AWS. And when I say we collected the AMIs, here is what I mean by it. So we collected the JSON definition of the AMI as just how it was returned from the AWS API. And we had some interesting information here. Like we have, for example, the description of the AMI, we have the name of the AMI, we also have some information around the volume, and the image ID, which is unique. And the description and the name are relevant because you can use them to find certain AMIs that are using certain technologies or targeting certain companies, right? And we also have the owner ID, which is useful. We'll see in the demo how we can abuse that. Now that we had our list of targets, we had to find a way to access the AMIs. And this method should be time and cost effective, automated, and as reliable as possible. We did a lot of trial and error. We came up with 4 methods to access the AMI, or at least try to, and some of them will work in certain situations, but only the 4th one was the right one for our use case. So first off, we tried to copy the ABS snapshot from the target AMI to our own AWS account. But we shortly noticed that even if the AMI is public, its volume is not. And it's not by default. It can be, but in most cases, it wasn't. And that's why it's very little overlap between our work and the work done by Ben Morris, where he scanned public ABS snapshots. Now, we tried to start an EC2 instance from the target AMI, create an ABS snapshot of its volume, and download it. which works, and it works great. It's also cost effective, but it takes a lot of time. For a volume of around 100 gigabytes, it takes 20-30 minutes to download, and I'm sure AWS would have blocked our IP in the end. So we couldn't have gone with that. Now, but we were getting closer, and we figured out that we have to work as much as possible within the AWS environment, and that's why we tried to just start an EC2 instance from the target AMI and connect to it. However, we quickly realized that this is not reliable because either we can't put our SSH key in the EC2 instance, or we can't use the SSM or other native functionalities to connect to the instance. But this got us to our fourth method. So here we start by having a secret searcher instance. This is an instance, we just called it secret searcher, but that's an instance that's already running and it's working in our own AWS account. Next, we start an EC2 instance based on the target AMI. And what we are doing next is essentially detaching the volume and reattaching it to the secret searcher instance where we can connect to it and analyze the data. It's like receiving a laptop that is not working, so you take out the hard disk and you put it in a laptop that works. So that's essentially what we did, and everything was happening inside the AWS environment, so it was as time effective as possible and also as reliable as possible. Now, I'll show you a demo on how to access the contents of an AMI, doing it manually. So here we will search for the description securitycafe.ro, and if we specify included, deprecated, and the region, we will get the AMI ID. But if we specify another region, we don't get the AMI ID, and also without the include deprecated, we don't get it. We can also search based on the owner ID, which is very powerful if you're doing bug bounty and you identify the AWS account ID. But let's stick with the description. We will take the image ID. We have some details, but first let's try to copy the snapshot of the AMI in our own AWS account. So we took the snapshot ID, we tried to copy it, but we get this error, source snapshot is not found. That's because the volume is not public, just because the AMI is. However, let's do the method with the secret searcher instance. So this is the instance that's already running, and now we will start an instance to the target, based on the target AMI. And once the instance is running, we will stop the instance because otherwise we can't detach the volume. But once the instance is stopped, we can detach the volume, and we no longer need this instance, right? We can terminate it and cut some cost. And once this volume is detached, we will reattach it to the secret searcher instance where we can connect to it, run scripts, automation, and access whatever files are within them. We use the web portal just because it was easier for the demo, but you can use it. You can also use SSH or any other way. Cool. When you are trying to mount the volume, you might encounter this issue, UUID collision, which was very weird, and we had to use XFS admin in order to fix that. But once you change the UID, you can mount the volume and essentially navigate the file system just like it was from your own EC2 instance. And we identify some access credentials, but we have to verify if they are still valid. And let's check if they are valid. And yes, they are valid from a user admin. And this is exactly how we felt when we identified our first pair of AWS access keys. And in the same day, we identified 10 more, and we knew we had something going on. Now, you can also use the manual approach, but we developed a tool that will scan one public AMI. So it won't scan the whole internet for public AMIs, but you can give it an AMI ID, and this tool will not scan it, but extract the files that matter to you. So this is another AMI. It had Bitcoin in the description, so we identified it. We take the image ID, and the tool is called Cloud Shovel. It is written in Python. And you only have to specify the region, a bucket where we will save the files, and the AMI. It will create all kinds of things. Essentially, it will do the process of the secret searcher method. And then it just uploads the file in this bucket, and you can go in the S3, find the files, and see what's there. A good way is to download the files. And after you download it, you basically navigate any files that you think it's interesting. And by default, we are extracting AWS access keys, Git repositories, .env files, and some other things. But it can be configured, right? And for example, in one partition of the volume, this AMI had another pair of access credentials, and actually the access credentials are still valid because we wanted to allow people to try our tool. So if you want, you can just search the AMI Cloud Shovel on AWS, and you will be able to perform the same thing and access the valid access keys. Cool. This is the tool, but we also have a QR code at the end with that points to the repository. This is how the overall architecture looked like. So we had the master EC2 instance, and in every region we had the secret searcher instance. And also in the same region, we started batches of 20 AMIs. We detached the volume from each one and reattached it to the secret searcher where we exfiltrated the data and analyzed the files. And after writing 1.2 K lines of code, 40 days of scanning time, and a bill of $450, we collected 500 gigabytes of carefully selected data. And I invite my colleague Matei to tell you more about it.
Cool. Thank you, everybody. So this is the secret searcher section. So in this section, and well, let me preface this. Thanks for being here this late. And I know you guys probably had the same amount of beer as coffee. So I'll try to make this as interesting as possible. So in this section, we are talking, or I am talking, about how we search for secrets and what sort of secrets we found. Now, the fun part comes when we show you what we were able to do using those secrets. So I am Matei Josephs. I'm a senior security researcher. I do a bit of threat hunting, a bit of pen testing, a bit of vulnerability management. But most importantly, I'm working on developing a family-owned business alongside my wife. That business is called HiveHack. Cool. Back to CloudQuarry. So our initial strategy for searching for secrets was, well, to be as lazy as possible. We wanted to avoid reinventing the wheel. There's so many known tools out there already doing this. One of them is Trufflehog. And yeah, we gave Trufflehog a run. However, our initial strategy failed. Trufflehog was very slow, produced several false positives, or at least for us. And while we would have been able to work through the false positives, the fact that it was slow was the main issue. Because, well, slow scanning meant our EC2 instances would run for a longer time, which in turn would lead to a higher bill, leaving us, well, broke and not only lazy. So we had to adapt, and we pivoted. For this, we went back to the Zen of Python. More specifically, this section of it. Simple is better than complex, complex is better than complicated, and special cases aren't special enough to break the rules. So with this in mind, we decided to become even lazier. So we started looking for specific types of files or directories. And these are environment secrets, secrets leaked within Git repositories, AWS credentials, SSH private keys, and a few others. So now we had to look for tools to help us do this. Ideally, simple tools that could allow us to look for files based on their names. And that was pretty difficult. We were just thinking, okay, where could we find such a tool? Well, there's your answer right there, find. And with this glorified one-liner or five-liner or whatever you want to call it, we started looking for, well, actually, we excluded the Windows directory, the program files directories, because these are full of junk. Sorry, Windows. We ignored everything that was above 25 megabytes because, well, we just didn't have time. And we started looking for credentials.xml, .aws, web.config, .env, .git, and so on and so forth. Now, our aim here was to create a valid proof of concept and not necessarily to find everything that could be found. Cool. So besides this very complex and proprietary use of find, and I'm just joking, we ended up setting up a few other things as well. Firstly, we needed some automations in place to verify AWS credentials, and you'll see in a couple of minutes why. We used Git leaks for checking Git repositories for secrets. We also set up some automations for validating some of the keys that we found, and for this we used KeyHacks, which is a pretty neat repository of methods for validating credentials and access keys. And lastly, unfortunately, we were left with a ton of manual work as well. But after our initial data collection phase, we found something along these lines. So a couple of million potential generic API keys, well over 100,000 AWS access keys, well, 1,000 or something Slack tokens, Stripe API keys, and so on and so forth. So a lot of stuff here. So you can probably tell why we needed all of these automations as well. However, focusing a bit on the AWS credentials, out of the 100,000 potential AWS credentials, only a bit over 120 of them were valid, out of which 20 were root. Now, I know that this does not seem like a lot. It's only 1%. But think about it this way. These AWS credentials allowed us initial access within over 100 companies. So let that sink in. And well, 20 of them root, so complete control. So now what? What's the next step here? Well, because we're the good type of hackers, we had to identify the owners. So we started looking for owner information, and in this case, we used the get contact information AWS CLI call, and we were able to get some data for some of the AWS account owners. Now, this revealed something very, very interesting to us. We initially thought that it'll be only boutique companies, very small companies which are affected. Well, we were surprised to see that some huge companies were affected. Some of the most valuable ones were worth $200 billion, respectively $50 billion. We found 3 huge companies in telecom, which you definitely heard about. We found 10 relevant companies in security and tech, and many other industries as well. So this was very interesting to us. It's not only small companies, it's also very, very big ones which are affected. Now, I know we may be playing devil's advocate, and we may ask, well, anyone can write whatever they like in their sort of account details in AWS, right? I could say that I work for Microsoft or whatever. And yes, that's true, but here we did quite a bit of OSINT. We found the owners on several websites, including LinkedIn, and it was funny to see that some of them had their AWS security certifications listed on their LinkedIn accounts, suggesting that they are able to properly configure these AMIs. Well, now, in terms of bug bounty, we're not too big on bug bounty, so we were very excited when we were able to report one of these issues on BugCrowd and got our first confirmed P1, so critical issue. So yeah, we were very, very pleased. Didn't really know what to expect. Now, just quick show of hands. Let's think about how much we made out of this P1 on one of the companies worth $50 billion. So who thinks we made over 5 digits, so over $10,000? Okay, a few hands. Well, thank you. How about 4 digits, so between 1,000 and 10,000? Okay, a couple more hands. And now let's go with the least amount possible. Let's say a few $100, so 3 digits. Yeah, and most people think we made 3 digits. Well, yeah, thanks for your support, but no, $0. That's what we made. Yeah, okay. Yes, thank you, thank you. And yeah, I'll be completely honest, this was a bit misleading because it wasn't a bug bounty program, it was a vulnerability disclosure program. So yeah, I mean, we didn't really expect to make anything out of it, but yeah, we were slightly disappointed that we didn't get this. But still, recognition, having a P1 on on BugCrowd, that's fantastic. However, we quickly moved on to our next story, something that I find even more interesting and definitely more profitable. And I like to call this story How We Earned and Lost $3 Million in a Week. Yes, so you can probably tell where I'm going with this. Well, remember we found a few Stripe API keys. Do you guys know what Stripe is? Who here knows? Okay, cool. Wow, I had no idea what Stripe was. It's a payment service not unlike PayPal. And very interestingly, we tried one of these API keys. It worked. And we found this amount. So 7 digits, USD. Fantastic. So of course we said, let's jump straight into the documentation and see how an attacker would go about extracting that money and putting that money into their own account, of course, for research purposes only. And while doing this, we encountered something different, and that is the fact that the amount is in cents. So what we thought was $3.1 million was actually 31,000. So yes, we lost $3 million just by reading the documentation. If there's any takeaway from this, don't read the documentation. I'm kidding, of course. Okay, so now after the initial wave of disappointment, we said, you know what, let's contact their security contact and let them know that we found this and that an attacker could extract $30,000 out of their account. And not only that, you can find a list of all their customers. And yep, we sent that email, and for a couple of weeks, all we got was radio silence. So no response whatsoever. And yeah, that was disappointing, of course. We thought, did we do anything wrong? Did we not prove impact? Impact, yeah. So that's what we try to do. We try to prove impact now. So what we did, we got subscribed to their cheapest plan, which was $9.99 per month. We found that transaction confirmed in the API, and then we did an API call to the refund. So, yep, of course, we were able to do a refund, and that was also confirmed in my bank account. Yep, so money was back in. Of course, now we knew that we could actually speak about money with them. So with a bit of extra OSINT, we were able to find their CEO online. We were able to extract their email address from there and send a new email. Within a couple of hours, we got a response. Fantastic. So now when it is about money, we're getting responses. Great. So we give them more details. We give them literally a full report with recommendations and everything they need to fix this issue. And then the CTO, which was CC'd into the email by the CEO, said, thanks for sharing the relevant information. We have made the AMIs private for now, and we'll be replacing the keys. Thanks so much for responsible disclosure. And I don't know why, this was a bit dull, so we expected a bit more from them. But it was okay, we moved on. There was a lot more data to dig into. However, 1 month later, I was forced to remember this issue. I checked my bank account, and I was getting charged $9.99. And yeah, it means I was so excited about being able to do the initial refund that I completely forgot to cancel my subscription. And to be honest, $9.99 doesn't seem like much money, but yeah, there was this sort of personal vendetta. I want to make sure that they're not getting my $9.99. And of course, the API key was still valid, so we were able to get the refund. Okay, but there's also some more impactful stuff still. For instance, we had access to, well, over 100 AWS accounts. We could have used their resources instead of ours, and this would have saved us about $450. Now, there's another area of impact which I find more fun and impactful, and that is AWS-based ransomware. So this could have given us free co-speaker travel money, so free hotels and travel. Now, I know that typically when we think about ransomware, we think about these complex code bases with lots of developers working on them, evasion techniques, and all this stuff. Well, once you have access to an AWS account, this is all you need. So yes, this one-liner is the AWS-based ransomware. It lists all S3 buckets, it downloads all the data in the S3 buckets locally, and then it removes all the data within the buckets. And instead of the data that they would have expected, the owners could find something along these lines. A ransom note. All your files have been stolen. You must buy us a Romania Bergamo plane ticket to get your files back. Now, I must say this. This is just a joke, okay? So we didn't do this, and we wouldn't do this, but it's pretty fun that we could have done this. Cool. Eduard, want to take over the responsible disclosure?
Yeah, the worst part actually. So we had a lot of trouble notifying affected customers because very few of them actually had contact details in the AWS account, but they had a website, and we had to go to the website, find a contact email, drop a generic email because we didn't know who will read it, right? And we sent about 70 responsible disclosure emails, but we received less than 10 responses, which was disappointing. And we did some weird things like involving the national cert in one case. I scheduled a sales meeting with a company just to tell them that the AMI, they have an AMI public with AWS access keys in it. And 90 days later, only 10 AWS keys were invalidated. And we had all the research done. We wanted to publish it, but these companies, they weren't allowing us because if we were to publish, we could have affected them, right? And we didn't want that. So in a desperate attempt to bring down the impact, we notified AWS, and we were like, hey, we have 120 AWS access keys. These clients, they are not invalidating them, so can you do something about it? And AWS was really cool. They went out of their way to actually help customers to invalidate the secrets, and only after a few days, more than 60 AWS keys were invalidated, so huge shout out to them. We had a meeting, we discussed about the research, some fixes, some ideas. It was a really good experience that gave us back the hope in doing responsible disclosure. However, let me tell you about a short timeline, right? So this week we wanted to check what is the number of valid keys now. So in April, 120 valid access keys reported to AWS. A few days later, more than 50, we only had 50 plus valid access keys. However, this week, we had 82 valid access keys. And all I can say is, what we believe the companies did, they received a notification from AWS, they panicked, they disabled the access keys, and God knows where, but between then and now, they re-enabled the access keys. And we don't know if the AMIs are still public, but their AWS keys are. And whoever has them, us, still has access to their AWS account. Cool. Now, Let's talk about detecting and defending, I guess this. So if your AWS EC2 settings are looking like this, you might want to look into it because you want them to look like this. So you want to enable these settings, block public access to AMIs and for ABS snapshots in order to prevent your engineers to make them public. If they are public, you might want to check if you actually have AMIs public. And you can use this CLI. Remember to check it on every region and include deprecated images. And if you have images and you didn't want to have, you might want to look for this event, shared snapshot volume created. This is the only event you get in your AWS account if someone uses your AMI to create an EC2 instance. And I have to say, you don't get a lot of information from it. You only get not even the source IP because AWS is protecting its customers. This is fine. And if you look in the CloudTrail, you only got the AWS account ID, which maybe AWS can do something about it, but you can't do much about it. Now, we had a lot of data besides the secrets, and we had some cool ideas to further extend this research. So we had 20K JSON Web Tokens, and we wanted to see if any of them have secrets or they have some misconfigurations, but nothing came of this path. We also had 4K unique SSH private keys. We generated a public key and a fingerprint. We used Shodan to find the servers, but no server came out of it. We wanted to perform the same research, but within the AWS network. Maybe some EC2 instances are whitelisting AWS IPs, but that was too much work and we didn't do it. And we also had a lot of Git repositories, and some of them I'm sure they are private, and we can look into them, identify the web applications in the wild, and maybe find some bugs. Now I let my colleague to end.
Cool. Let me jump straight into the conclusions because I'm aware of your time. But I mean, yeah, you're definitely getting what you paid for here. So, all right. So, in terms of our conclusions, the impact of this research is actually not yet fully unveiled. So we only did a proof of concept. There's a lot more to find out there for sure. Also, security by obscurity is definitely insufficient. I bet a lot of developers thought that their Git repositories are safe because they're private. But how is anything private if it's placed in a public resource? Also, mass exploitation, very, very easy. 2 random security guys from Romania were able to do this. Think about what real threat actors could do. Now, also, there's still a lot of interesting things to find in public cloud resources, in AWS, other cloud providers, and we encourage you to go and explore. Feel free to let us know. Contact us on LinkedIn, X, or other platforms if you have any additional questions, and we'd be very, very happy to help you with any of your research. This being said, thank you very much, everybody.